Today we're going to take a look at a pretty neat topic that comes out of calculus, is the study of money flow. Usually money is coming into your company at a continuous rate. We're going to use the word continuous very loosely, but the idea is you sell widgets and you sell widgets continuously throughout the year, and so money is continuously coming into your business. So this idea of continuous money flow is when we're looking at the rate at which the money is coming in. We're really looking at the change in your account. So if we know how to model the change in your accounts, or the derivative, because the derivative is change, we can make predictions about how much money and income we have to work with. So first, let's talk about this concept of total money flow. In other words, the total money that comes in, or I guess gets deposited in, or however you want to think about it. The total money that comes in over time. To get that total, we'll have some function where f of x is amount deposited at time x. So at any given moment, the amount that's deposited, the amount of sales you make at that moment, is modeled by f of x. The total money flow that comes in is going to be the integral from 0 to t of f of x dx, where t is the amount of time. In other words, if we're looking at a 7-year time frame, t is going to be 7. Basically, we want the area underneath the function. So the height of the function is going to represent the amount of money that comes in. So the area underneath is the total amount of money that's come in between time 0 and time t. And that's what we're integrating. We're finding that total amount of money that's come in over time. So, for example, if $2,000 is invested and each year the amount invested increases exponentially at 8%. How much is invested over the next, let's say, 5 years? What is the total amount of money invested? So the idea is we've got $2,000 invested in the first year, and then, well, continuously over the first year, and then increase 8% continuously over the next year, increase 8% continuously over the next year. 5 years, 5 times 2,000 is about $10,000, but with interest we would expect to get a little bit more. So let's see what happens. First, we need to know what the function is that we're working with. When something increases exponentially in these continuous environments, you remember we have the equation PERT to help us out. So in this case, f of x is equal to the principal investment of 2,000 e to the increase of 0.08 times time x. And that tells us how much is going in at any given point in time along the way. To find the total invested, then, we integrate this function. We take the integral of 2,000 e to the 0.08x and integrate it over the 5 years, 0 to 5. And we see what we have, dx. Well, we have e to the 0.08x, and then we divide by 0.08. And let's see if 2,000 divided by 0.8 is a pretty number. It is. It's 25,000. So we'll go with the pretty number. If it wasn't a pretty number, I'd keep it as a fraction. And we're going to integrate this from 0 to 5. So when we plug a 5 in, we get 25,000. E to the 0.08 times 5 is 0.4. Minus 25,000. E to the 0 is 1, so that goes away. And so on my calculator, 25,000 e to the 0.4 minus 25,000, we get a total of $12,295.62 when we round is invested over those 5 years. So maybe I'm selling widgets. Sales are increasing 8% per year. Over the next 5 years, I'm going to bring in $12,295.62. That's this idea of total money flow, the total money that's come into my account, not including the interest, is $12,295.62. Now, I might be interested in how much are these payments worth over time. And this gets into the idea of what we call the present value of the money flow. So here's the situation. I have a fire in my warehouse and it burns down my product, my machinery. My business cannot function currently. So I file an insurance claim. And my insurance claim, I don't want to just replace the product loss, I also need to replace my income lost. Well, the insurance company is going to want to know what is the present value of the income lost. In other words, what is a lump sum amount In other words, what is a lump sum amount that would have the same final amount with interest as the continuous money flow. In other words, the insurance company has to replace your income for the next 3 years that it's going to take to get your business back on its feet. To replace your income for the next 3 years, they're going to pay you the present value of that money so that it would accumulate with interest the same amount of time over those 3 years. The formula for this, to find that present value, we are going to take the integral from 0 to t of the function times e to the negative rt, I'm actually going to say negative rx, e to the negative rx dx. This is the second big formula of the day. The first one we already saw was the total money flow. Is just the integral of the function. For the present value, we take the integral of the function times e to the negative rx. So for example, let's say the expected annual income for the next 3 years of widget sales is f of x equals 75,000x. we're going to find the present value of sales if interest is 8%. So maybe something's happened and I'm filing an insurance claim. I've lost 3 years of widget sales because of a major fire. So I need to recoup not just my lost product, but also my lost income. So we're going to calculate that lost income for the insurance company to see what type of check I can expect to receive. To find that present value, we take the integral from 0 to 3, because we're replacing 3 years of income, of f of x, which is 75,000x, times e to the negative interest rate, which is 0.08, times x, dx. How are we going to integrate this? We can't use substitution this time, so we're going to use integration by parts, where we take our derivative and an integral, because 75,000x is going to quickly go to 0. The derivative of 75,000x is 75,000. The derivative of 75,000 is 0. So the other part, the e to the negative 0.08x, the derivative of that is e to the negative 0.08x divided by negative, I'll make the whole thing negative, 0.08. And the derivative of that is e to the negative 0.08x divided by another 0.08, so I'm going to say 0.08 squared, because we've done it twice, and this time it's positive. Tic-tac-toe. First one's positive, next one's negative. We have negative 75,000x e to the negative 0.08x divided by 0.08 minus 75,000 e to the negative 0.08x divided by 0.08 squared. And we're going to integrate that from 0 to 3. When we plug 3 in, we get negative 75,000 times 3 e to the negative 0.08 times 3 is 24 over 0.08 minus 75,000 e to the negative 0.24 again, all over 0.08 squared. Then we subtract, so this is going to change our signs. Now it's a plus 75,000 times x, which is 0, e to the negative, well, e to the 0, over 0.08, and that's nice because there's a 0 multiplied in there. Anything times 0 is 0. Plus, because we have to change the sign, distributing the negative through, 75,000 e to the 0 over 0.08 squared. And anything to the 0 power is 1, so we don't even really need the e to the 0. So that cleans it up a little bit, so we can type it all into our calculator. Negative 75,000 times 3, e to the negative 0.24 divided by 0.08, minus 75,000 e to the negative 0.24 divided by 0.08 squared, just squaring the 0.08, plus 75,000 divided by 0.08 squared, and we find out that the present value of my 3 years of widget sales is approximately $288,063.89. In other words, if I put $288,000 in an account right now and left it there, at the end of 3 years, it would be the same as if I invested this money continuously over the 3 years. So let's compare that with the actual money flow. We're going to find the total money flow. And remember, the flow is the integral from 0 to 3 of the function, which was 75,000x dx. This integral is much simpler to solve. We take x squared, divide by 2, and that becomes 37,500. We're going to integrate that from 0 to 3. Plug 3 in, and we get 37,500 times 3 squared minus 37,500 times 0 squared, which is nice because multiplying by 0 makes 0, equals the actual money flow that I've lost is $337,000 and $337,500. So my lost income, my present value, what this means is, over the next 3 years, I expect to bring in continuously over that time $337,500. That would be worth the same amount as if I stuck the $288,000 in an account and left it there for 3 years and never came back, never added to it. So the insurance company is going to cut me a check for $288,000 and say, there you go, invest it as you wish to make up for your lost income. That's your present value of money flow. One last thing we can look at, though, is what you're probably most interested in as a business owner, is your accumulated amount of money flow. Or the total money flow plus the interest earned. How much interest are you going to earn? The formula for the accumulated amount we've seen before is PE to the RT. That is your third formula, and you probably already know that. The key is here where P is the present value of money flow. In other words, what we just calculated, the present value for the insurance company. So let's find, speaking of that example, let's find the accumulated money flow of widget sales above. So we just found out that P, my widget sales from above, in pink here, is $288,063.89. So my final accumulated value is that $288,063.89 times e to the, we said the interest rate was 0.08. It's for 3 years. Type that into our calculator, and the accumulated amount is $366,200.98. That's how much money we have made. You might be also interested in how much was interest. Well, if we've got a total of $366,200.98 over the 3 years, we just have to subtract off how much we actually put in there. And what we put in was continuous over the entire amount of time. That was the actual total money flow. How much total money flowed into the account? $337,500. $37,500. And when we subtract, we're going to get our interest. Our interest over those 3 years was $28,700.98. So that's our idea of continuous money flow. We've really got 3 equations that we're working with. Total money flow is the integral from 0 to t of f of x dx. That tells us how much money comes in from our sales. Present value of the money flow is the integral from 0 to t of f of x times e to the negative rx. That's going to tell us what lump sum now is equivalent to continuous deposits over the time. And accumulated money flow is A equals P e to the RT. That tells us how much money we have in both deposits of the continuous money flow, the total money flow, I should say, plus the interest earned on that money. So let's do another example where we walk through all of that. So we'll set it up here, and this isn't going to be on my screen for the entire problem, so make sure you get this written down so when I reference it later, we're okay. Let's say the rate of continuous money flow starts at $10,000 for your company, and increases exponentially at 5% per year. And let's say for 4 years. Interest rate now is 11% compounded continuously. So that's my situation. First, we're going to find the function for money flow at time x. So the function for the current money flow, the amount of money that's going in right now, not the total, but just right now, is 10,000 to start off with, increases exponentially, so we have e to some exponent, which is the rate times time, 0.05 times whatever time we're at x. So that's our function. Now we're going to find the total money flow. $10,000 for 4 years, we would expect it to be a little more than $40,000 adjusted for the increase that we have. So let's see what that's going to be. Total money flow is the integral from 0 to 4, the integral over time, of our function 10,000 e to the 0.05x dx. Well, the integral of that is e to the 0.05x, and let's see if we can do 10,000 divided by 0.05. Yeah, that comes out nice. That's 200,000. We're going to integrate that from 0 to 4. So we've got 200,000 e to the 0.05 times 4 is 0.20. Minus 200,000 e to the 0 is 1. And so for total money flow, 200,000 e to the 0.2 minus 200,000 is going to be $44,280.55. That is the amount that is going to come in over the next 4 years. That's the total money flow. We also can find the present value of the total money flow. The present value is how much that money would be worth as a lump sum today instead of continuous income over the next 4 years. For the present value, that's the integral of our function, which is 10,000 e to the 0.05x. And then we multiply the function by e to the negative interest rate times x. The interest rate above in your notes you should see is 11%, so negative 0.11 times x dx, and it's over the 4 years, 0 to 4. Let's simplify this a bit. We've got the same base on the e's, so let's add those exponents. So we have 10,000 e to the 0.05 minus 0.11 is negative 0.06x dx. And when we take the derivative, we get e to the negative 0.06x. And when we divide by negative 0.06, it's not a pretty number. So we're just going to say negative 10,000 divided by 0.06. So we don't lose any accuracy with rounding. We'll just keep that as a fraction. And we're integrating from 0 to 4. So plugging 4 in, negative 10,000 over 0.06 e to the negative 0.24. 0.06 times 4 is 24. Minus a negative, which changes it to a positive, 10,000 divided by 0.06 e to the 0, which becomes 1. And so we can type this into our calculator. Negative 10,000 divided by 0.06 times e to the negative 0.24 plus 10,000 divided by 0.06. And the present value of this money is $35,562.02. In other words, if I had a lump sum right now of $35,562.02, and I stuck it in an account, after 4 years I would have the same amount of money as if I put in that continuous flow of money over the next 4 years. So how much is that total amount? We can find the accumulated amount of money flow. The accumulated amount is the present value amount, which we just found was $35,562.02, times e to the interest rate. We said here the interest rate was going to be 11%. Times the amount of time. We said we were going to do it for 4 years. And so if we take the 35,562.02 times e to the 0.11 times 4, it's 44. We get a total accumulated amount of money that we expect in the next 4 years to be $55,217.41. So money comes in over the next 4 years continuously using this equation. After 4 years, it's now worth $55,217.41. So how much was interest? Well, we take the total money that came in, 55,000, let's do it in a different color. 55,000 $217.41. We subtract off the total money we put in the account. The money we put into the account, that's the total money flow of $44,280.55. And when we subtract, we find our interest was $10,936.86. And that is how we can use calculus to help us understand how the flow of money is affecting our financial situation. 3 formulas, take a look at them, do a couple practice problems in the book, come to class with questions, and we will see you then.